Okay, so today we are talking about levers and mechanical advantage. So you have first class, second class, and third class levers. And the difference between these three types of levers is what is in the middle and where the fulcrum is. So in here, the fulcrum is in the middle with the force of the effort being applied, and the force of resistance is on either side of the fulcrum. Here, the resistance is in the middle. And then here, the effort is in the middle. Fulcrum could obviously be on either side, it could be exchanged, but it's what is in the middle that really makes it a first or a second or a third class lever. A first class lever can be a typical seesaw that you used to play on when you were younger, or even now, I won't judge. But this would just be the pivoting point of the seesaw, or in a real biological anatomy case, it could be here is your spine, your axis and your atlas perhaps, where your head can pivot. And the effort of your muscles is maybe pulling your head to one side. And then the resistance or the weight of your head that has to be overcome is coming on the other side. So don't get too worried about the arrows being different here and here. Just worry about that the fulcrum is in the middle. This is where your head is pivoting. So a second class lever is about the resistance being in the middle. And the best way I can describe this is with a wheelbarrow. So you have your fulcrum or the wheel on one side, the resistance of your dirt, your gravel, your whatever in the middle, and then the effort you pulling up on the wheelbarrow to move it around is on one side. The third class lever, the effort is being applied in the middle of the lever. So here, let's say you're doing some bicep curls because you want to get ripped, and the fulcrum would be where your joint is, where your elbow joint is here. And then the biceps inserts on the other side of the elbow, and that's where the effort is going to be applied because that's where the contraction happens and it causes it to raise due to this contraction happening up here and it inserting across the elbow. So the effort is being applied here, and then here's your weight. I'm too lazy to draw a hand, I'm sorry. Is coming down this way, the force of resistance. So this is obviously the resistance because that's the heavy thing. And so here, effort is in the middle, fulcrum on one side, resistance on the other. Now, let's talk about mechanical advantage. So mechanical advantage tells you what kind of muscle, like what your muscle was built for. Was it built for speed and resistance, or was it built for force and strength? Was it built to go a longer time, like maybe in a marathon runner, or was it built to just have one more exclusive big show of force? Mechanical advantage can be shown by the length of the effort arm divided by the length of the resistance arm. So in a typical seesaw example, let's say your friend is pushing up on this side and you are sitting on the other side weighing it down, and they're sitting 0.9 meters away and you are sitting 0.75 meters away. So the effort arm would be here, so it would be 0.9 divided by 0.75, and the mechanical advantage would be 1.2. So that'd be a typical first class example. Because this isn't necessarily a muscle, we don't have to talk about this. But if we did, it would technically be for force and strength because it is above 1. If it's below 1, it would be for speed and distance. So in a second class lever, let's say you are sitting down and let's say your cousin had a new baby and you are bouncing the baby on your leg. So the baby is sitting right here in the middle of your leg, and the fulcrum is your hip joint right here. And then effort from your muscles is being applied to move your leg upward this way. So the baby is sitting, let's say 9 inches away from where the fulcrum is. And then the length of where the effort is being applied is 15 inches away. So you're going to do 15 divided by 9, and you're going to get 1.67. And so because that is above 1, the muscle is made for strength and force. Now for a third class lever, we have our same example from up at the top. Here's your biceps, and here's the exerted force, and here's the resistance. And then let's say the length of the effort arm from the fulcrum to where the muscle inserts is 2 inches. And then let's say from the fulcrum to the weight is 12 inches. So it'd be 2 divided by 12, the length of the effort divided by the length of the resistance, and you get 0.2. And because that is below 1, you get speed and distance. Okay, so mechanical advantage and levers are super important to know just the general idea of how your body uses its bones and uses its muscles to move around. Your body is using your bones as levers to pivot around joints and to actually cause your body to move. So that's why it's important to just have a general understanding of this, especially as you go forward in whatever career path you have chosen. I hope this helped and have a great rest of your day.